you are home and you're off. Hopefully you're enjoying yourself. But I made a video for you of the Unit 1 practice test that you're going to do online. And I want to go through the solutions. So to make sure everyone has this correct, your test will be on Tuesday or Wednesday, and it will be over the Unit 1 test quiz that you've already taken, and this Unit 1 practice test, and anything else we've gone over for this year. So be prepared, study, study, study. Again, I won't be here Monday. I have an appointment, a very important appointment that I will tell you about another time if you just ask. But Tuesday and Wednesday, we have the test in class. If you didn't show me any of the binder assignments, you can show me on Tuesday and Wednesday during class while you're taking your test, okay? Great. If you have any questions over the weekend or whatever, just send me a message and hopefully I can help you, okay? Great. High fives. All right. I thought I'd start with this one, but this one gave me a little trouble when I was going over it. This one says x cubed minus 27 over x minus 5. And just to note, if I click this, okay, well, what's nice about this one, it worked on the other problem. It gives me the same answers, the same question each time. Some of the other ones, you have different problems, but I think everybody has the same question for this one. So if you missed this one, that's just a shame because I'm giving you the answers. That means you didn't watch the video. This one says find the y-intercepts, but how do you find the y-intercept? Well, the way you find the y-intercept, I worked it out somewhere. The way you find the y-intercept, to make a long story short, remember your y-intercept is just when x is 0. So all you gotta do is plug a 0 in for x. If I plug a 0 in that numerator, which I did over here, 0 cubed over 0 minus, that one was, oh, this one's a little different. This one's 5. So in that case, the problem does change. So I'll rewrite this. So I'm going to plug in 0 to the third minus 27 over 0 minus 4. Well, negative divided by negative is positive, so it's going to be 27 over 4. So that's why that's the y-intercept. Easy enough? For the x-intercept, that's where the graph crosses the x-axis. You can do that by hand, but don't. Just use your software. Use your tool. So I'm going to show you how to do this in your TI-84, because this is what you're going to have on the test. Let me see. For this one, I think I had another example. So now I'm going to go to change this to a 4. And now I'm going to hit graph. Now, your graph might not look, if I'm going to hit zoom, this graph was kind of weird, and this is important here. I'm going to hit zoom and Z standard. I notice that 1, 2, 3, 4, 5, there should be a vertical asymptote here because I have x equals negative 4 here. So in doing this problem, I'm going to learn that this isn't all of the graph. Sometimes that happens. And if you think that's going to happen, if I go zoom and then go to Z fit, because sometimes Z fit will give you a better graph. So you can see everything. So if I hit enter, voila, that actually gives me all of the graph, which is really important. But for this, we need to find the x-intercept where it crosses the x-axis. So I'm going to go second, trace. I'm going to click on 0. 0, intercept, solution, or root, they all mean the same thing. So that's how I'm going to find that where it crosses the x-axis. Go to 2, hit enter. It's asking that question from class. I want to go a little bit to the left of my x-intercept is about here. It looks like it's just 3. So I'm going to go right there, will be good. A little bit to the left of it. I'm going to go a little bit to the right of it. So I'm just going to move it maybe here. I know that's a little bit to the left of that point. Doesn't have to be exact. It's saying guess, hit enter again. Voila. My solution or 0 is 3, which is good. I don't know if it's good or bad, but it is just 3. Let's see if I can find it. I got too many windows open here. So for this one, my x-intercept was 3. Okay. The next one, it says we're looking at vertical asymptotes here. That's looking at your denominator. If I factor my denominator, or what number can I plug in to make that 0? If I plug in a 4, that's going to make that denominator 0. That's why I have one vertical asymptote at x equals 4. All right, the next one, it looked like it's referring to horizontal vertical asymptotes. This one, we didn't cover. Well, I know this is a type 3 function, okay? It's not one difference in the two numerator exponents, so it's not type 4, it's actually type 3. So it has no horizontal or slant asymptote, okay? So, but it doesn't have that option. So honestly, if it was me, I would have left off this last part, but they want an equation for an in-behavior asymptote. We didn't calculate an in-behavior asymptote. It's not hard. You just do long division, but we didn't talk about that, so that will not be on your test, okay? This is just a graph here again, so make sure you just go and look at your graph and match it up with the graph there. There's nothing more to it than that. Let me pull up that graph, see if I can find it. I think I had that in Chrome. There's our graph, just so you can have it there and you can see it. But again, sometimes if your graph doesn't match, that's simply because you need to either do zoom fit or zoom standard to get it back to normal. And no, I can't help you with that in the test. Just want to let you know right now. All right, here, the next one, you have some limit function stuff going on here. Well, here, it's going to be this one. It says there is one vertical asymptote. We know that. And this is describing the in behavior. Let's see, remember if y'all understand and remember how this works. This little negative to the right means from the left. And we're looking at 4. So we're saying limit of f of x as x goes to 4 from the left. Well, remember 4, this is 1, 2, 3, 4. There's a dotted line going straight up here. So is it this graph, the blue one, gets closer and closer from the left to 4, it goes down. So it goes to negative infinity. That's why that was negative infinity. The other one means from the right. So as we go from the right, it's going up, up, up. That's why that one is positive infinity, okay? Hopefully that helped. Great. All right. The next one, they want a local minimum. Local, Why does it have a local minimum, local max? That's going to be, might be better to see. I think I did the same thing with this one here. I think I changed, this one's 4. Okay, well, that looks like a mess. Let's take it back to normal. And this one here has a local min, which is here, and a local max, which is here. So the way that works on this calculator is easy. All you do is click what you think it's about, and it actually gives you the point here. On the graphing calculator, I think we talked about that in class. You're going to use your minimum or maximum function to do that. So here, the minimum is negative 1.355, which they rounded to 3 places. And the local max is this number here. That's it. Okay, for that one. All right, the next one, they're looking for the domain. And the way they wrote it, they have it in interval notation. Because remember your domain, remember you have a vertical asymptote of 4. So that's the only thing where it's undefined. So that's going to be a domain from negative infinity up to 4, not including 4, union 4 to positive infinity, okay? The range is all reals. That's because there's no horizontal or slant asymptote, okay? But sometimes even if there is a horizontal or slant, it still can be all reals. Just depends on the graph. All right, so this next one, it says the function is continuous on all real numbers. It's continuous. Graph has no symmetry. Symmetry means if you can fold it about the y-axis, the same thing on both sides. If it says symmetry about the origin, let me explain what that means. Symmetry about the origin means if I were to, and you don't have to graph it every time, but just want you to visualize. If I were to graph the line y equals x, if my function was symmetrical about the origin, it'll be symmetrical about this line. Let me show you one that is symmetrical about the origin. Okay. If I were to graph y equals x, this is actually going to be the next unit. X to the third. This function here is symmetrical about the origin, which means you can flip it about this line y equals x. Okay. So again, we haven't talked about that a lot, so most likely that's probably not, we're not going to be dealing with a lot of them there, but again, they're just getting you familiar with it. All right. What else? The next one, graph is unbounded. That means the graph increases or decreases to infinity. So this original graph here, which was the one in red, it increases or decreases forever without bound. And you kind of get that when you were looking at the doing those limits. So it's going to increase or decrease without bound. That's why it's called unbounded. That's why we describe it as being unbounded. All right. And the next one, you want your intervals of increase or decrease. We talked about that in class. The function is decreasing on this interval and increasing on this interval here. And if I go back to my graph, let's get rid of this one. Gonna take it back to home. It's going down, down, down up to this point here. It's increasing here, then it's going down, down, down here as well. So in this graph also, remember, there's another section of it on the other side of this. So you also need to look at this section over here, where it's decreasing and where it's increasing at. So you're going to just write out those intervals. So just take a look at this and hopefully this helps. This will might be a bonus question on the test, a problem like that. So the rest of them I think are pretty self-explanatory or we went over in class. So I'm going to kind of scroll through so you can kind of see the solutions for some of these. Hope that'll help you while you're working on yours. And remember, yours might not be exactly the same, or if I'm scrolling too fast, just hit the pause button to kind of help you to see your problem or how to do the problem that's going to help you. Hope this is helping. Let me click and see if they give me another problem. Excuse me, there's another problem. So the problem, again, the problem that they give you for these, they're all similar, so everybody doesn't have the same problem. All right, let's look at the next one. This one is a type 2 function. Here are some solutions. And the rest of these, I think before that, they're all, I would like to say normal because they're all kind of similar problems that we've done before. So hopefully it's helping. So again, if you had plans today, hopefully you've finished everything and you can just not worry about it. But other than that, you're going to just study. Make sure you go through everything so you prepare for the test on Tuesday, Wednesday. You will have no new assignments until then. You're just going to come in, work, practice, and make sure you prepare. If you have questions, let me know.